What if there was a data structure that allowed you to search for elements in constant time? Sounds crazy, but it's not. Today's lesson, hash tables. So you've been working with vectors for a while, and you're probably used to the whole insertion is constant time, deletion, at least pop back, is constant time, and then search is linear, right? There's really nothing you can do about that. You want to search for an element, you got to check every element, because if you don't check every element, how do you know that the element wasn't there in an element that you didn't check? And that's fine for some purposes. There are some advantages to vectors, but hash tables are really neat. And so today we are going to talk about these wonderful data structures that can search for things, insert things, and delete things in constant time. Cool. So a hash table you can pretty much think of at its base as some array. So here's our array, and it has some amount of elements. And basically what we want to do is we want to be able to take some data type, map it to another data type, and put that pair into one of these spots where we can find it easily. So let's say we want to map a string to an int. Let's say we're writing a program that counts the number of occurrences of any unique word in some body of text. So we're going to map a string to an int. Okay, and in C++, by the way, this is implemented in unordered map in the standard library. So what a hash table does, the heart of a hash table is the hash function. So if I give a string to a hash function, what I want is to be able to give this a string and have it say, hey, that string goes here. So the way we do that is we have some hash function. I'm just going to display it as a black box for now. And this hash function is usually something like, say, let's add up all like the 1 to 26 integer values of the chars in the string, and then mod it by like the size of this array so that it fits. But for now, let's just say we have the string frog, and it goes through a hash function here, and it says, hey, Austin, that should go in index 3. Okay, so cool, 0, 1, 2, 3. So here we go. So frog should go here. Now, there are a couple ways to insert stuff into hash tables. What we're going to do today is called separate chaining. You should learn about all of them in class, I think. But basically what it's going to do is this element of the array is now going to point to another array that we allocate here. And the first element of that array is going to be associated with frog. And let's say for this program we're writing, we want to say how many times did frog occur. So let's say frog has occurred 1 time. And then it'd be pretty easy to say if frog occurs again, we want to increment the value in here. So let's go again. Let's just say the next word we encounter is toad. So we have toad goes into our black box, and it spits out 0. So here we go. Here's element 0. So now we're going to say, all right, well, element 0 now is going to point to this array that we allocate, and it has some amount of elements. And here is toad, and toad has occurred once. All right, so far everything's going pretty well. We're inserting in constant time. So what if we want to search for something? So how that's going to work is we say, hey, unordered map, I want to search for the word frog. And it's going to say, all right, Austin, well, let me just put that through my black box hash function here. Looks like that should be in element 3. So I'm going to go 0, 1, 2, 3. There it is. Okay, and notice that's just me counting. So the computer doesn't have to do that. It doesn't have to check. It just goes right to 3 because it knows, hey, go to 3. And so it goes to 3, constant time. Goes over here, constant time. Checks, is the key to this frog? Because that's what you put in. Constant time. Checks. Sees, all right, frog has appeared 1 time. Now, you might be thinking, hey, what's this array doing here? It looks like you might have to search through that at some point. And you're not wrong. So the nature of a hash function, right, is that we have 7 elements here. So there's a lot more than 7 words in the English language. And some of them are going to hash, given that modulus hash function that we gave. Some of them will hash to the same thing. So let's say the word wind. Also, we put it through our black box. And, oh man, it hashed 2, 3. So we're going to go to our third element right here, and we're going to go over here to this array, and we're going to say, all right, looks like something's already here, so we're going to go to the next one, and that's going to be wind, and wind occurred once. Same thing if we want to search for wind, say, hey, I want to search for wind, put it through the black box, get 3, go down here, 0, 1, 2, 3, and then we go over here, and now it's getting to the point where it looks like this might become like a linear search, because if a lot of stuff gets hashed to 3, let's say we have n words, and they all happen to get hashed to the same thing, then all of a sudden, searching is big O of n, because this is all just a fancy way to search through one array. So the idea behind hash tables is that that's generally not going to happen. A good hash function will distribute stuff evenly, and you'll end up averaging out to constant time searches. And there's something called the load factor, where when a certain amount of these boxes get taken up, you start to say, all right, well, stuff's getting hashed to the same thing a lot, and we're getting these really long arrays on these chains. Let's double the size of this array right here. So we're going to double this array. We're going to erase all this. We're going to rehash everything in here to the new mod size of this array. And all of a sudden, these arrays get cut down to a reasonable size, and our search is linear again. Or I'm sorry, is constant again. So you can see how this kind of takes up a lot of memory. It's kind of heavy in that regard. But the search, constant insertion, constant deletion. Deletion is just searching and then deleting. So all of those things are constant time, which is a pretty incredible thing for a data structure to be able to do. So hash tables, look them up in the docs. Use them when you want to search for things in constant time. They are great, and you will also learn in class about open addressing, which is a little bit more tricky, and you will be doing a lab on where you actually implement a hash table. So I hope that you are as big a hash table fan as I am now. They're pretty cool, and I will see you later.